Thank you all for coming to my talk. I want to talk with you about server-side tagging. This is not a spelling mistake. It's not about server-side tracking, even if it implements tracking, but it's actually about tagging. What I will be talking about is about using a tag manager, kind of on a server side, which put you in more control of the data that the tag manager is transferring. The goal of this talk should be that I explain the concept to you, why it was introduced. I will give a demo, how it can be implemented, what benefits you can get from it, and if the time is, and if I'm good in time, I will quickly show how to set up a simple setup with server-side tagging. So these are the parts of my talk. Oh no, not okay. This thing doesn't like white space. Okay, okay. Yeah, my name is Tim Schreiner. I'm a Typo 3 developer at KM2 GmbH in Düsseldorf. And even if I'm a Typo 3 developer, this talk has nothing to do with Typo 3. This is absolutely standalone for server-side tagging. Click. Yes. So, what is a tag manager? Short question. Is someone here who doesn't know what a tag manager is, hasn't contact with it? Okay, no one? That's great. Then I will make this quick. So, I think a tag manager is a concept that was introduced a while ago to give mainly marketeers the ability to manage their tracking codes on a website and to improve it. So that they can add the event data that will be tracked on several actions the user or the browser will execute. So this is, I think, a good summary for a tag manager. Short part, how does a tag manager generally work? First of all, I will talk about the naming conventions, because in the first time they might be a little bit misleading. So it was for me. So first of all, we have a tagging container. A container is something like a project you create, which contains all your configuration. So all the configuration you do is stored in one container. Second, there are tags, where the name is coming from. Tags are, in a simple way, tags are just scripts that gets loaded when you load the tag manager. Nothing more, especially Java. It's JavaScript. I don't think there is any other kind of script. And third one, there are events, which are like browser events that will fire or execute the configure tags. So the tag code is loaded, and when an event is fired, the code gets executed. This, to put it in a simple way, this is what a tag manager generally does. Yeah, so about the execution order, I just introduced. First of all, when we build a website, we get some tag manager code from our marketeers. They tell us, hey, please put this on the website in the head tag. We do that, and this script is loading the tag manager script. For Google Tag Manager, it's some gtag.js, but there are also other tag managers. I just want to mention that there's not only the Google Tag Manager, but this talk will be mainly about Google Tag Manager. Yeah, as we see, the website loads the tag manager script in the server in the web container. Sorry, there's a spelling mistake. In the web container, this is the default tag manager setup. There are several tags. In this case, a Google Analytics 4 tag, Google Analytics via event tag, and some Facebook pixel that will get loaded. The website loads this data, and when the tag gets executed, for example, by a page load, the scripts will be executed, and for Google Analytics and Facebook, the tracking data is directly sent to these two platforms. So you have no control where the data is going with the setup, and this is a really problem with data privacy for us, like GDPR. So, as I told you, problems with the Google Tag Manager now in this case. First of all, we load a third-party script, which might get restricted by browser configurations, especially for setting cookies. I think this will get worse in the next 1 or 2 years, that there will be more and more restrictions for third-party scripts setting cookies in your browser. I think even Chrome tries to get rid of all the cookies from third-party scripts, but they have some other solutions for that. Their own solutions. As I said, you are, especially for Google Analytics and Facebook Pixel, you aren't allowed to load these scripts directly without consent of the user. Even the Tag Manager script, I think you aren't allowed, because when loading the Tag Manager script, your IP address is directly submitted to Google by loading the Tag Manager script from their server. So even this might be a problem. And the third problem is the content security policy. The content security.
I consider that as an advantage.
Yeah, I will come to that. Right now, I think. It's a good thing. So, in my opinion, the Tag Manager was introduced 10 or 12 years ago. Then marketeers has control over what scripts they want to load on their website, which wasn't a great time, I think, for developers, especially when you look into performance of a website, and some marketeers are pumping in Java scripts. In the worst case, they found them on some website. This is a cool script, paste it there, and faster than you can see, you might have some Bitcoin mining on your own website because the JavaScript is loaded. So in terms of security, the content security policy was introduced, which gives the developers back the control what scripts can be loaded. So even if the marketeers put new scripts in their Tag Manager, the developer has to allow these scripts in the content security policy. So yeah, 1-1 for developer and marketeers. Now I introduce the server-side tagging, which ships around these, which can ship around this, the content security policy a little bit. How it's done, we see in a short time. So server-side tagging. To put it simple, it's nothing more than a proxy. So every data that is transferred from Tag Manager to the website and from the website back to the Google Analytics or Facebook platform can be proxied by this server container, and you can transform. You have full control of the data. You can cut out data, you can add data, you can change data that is sent to and by the client, also the browser. The great benefit is that all the scripts can be delivered from a custom domain. So when we have the website km2.de from our company, we can load the Tag Manager from tracking.km2.de, which gets rid of the problem with third-party cookies, because now it's a first-party cookie. It's from the same domain, just a subdomain. But it counts as first-party. And as I told you, When data is sent, you can transform this data in real time. We will see an example later on what it can be used for, especially for privacy concerns. So the server-side tagging. To be able to keep the data on your server, you need to host the server-side container somewhere. Google by itself provides a special wizard where you can host it on the Google Cloud platform. But you're also able to host it on your own server using Docker images. Google provides for their server-side containers Docker images, which are node-based. You can set up these on your server. It's quite simple. I will hopefully show this in the setting up demo later on. Next step is you have to configure the tag manager containers to use this your own server-side tagging container. Yeah, I think that's basically it. Oh, that's all. So, 15 minutes in, it's demo. So, I was a little bit quicker than I have thought, but it's okay. We might have time for the setup process then. So, or more discussions. So, good point. Are there questions till now? Concerns? Yes.
The container which is provided by Google?
The image is provided by Google, yes, correct?
The image is provided by Google,
yeah.
And we must trust Google that there is nothing done evil with the data.
I thought that this question would come up. By now I have to say yes. I couldn't find the source code, how the container is built. It is hosted on Google's registry platform, but couldn't find the source code. You can look into the Node.js files inside the container. So they aren't encrypted, but they are minified. So isn't that cool? Yeah.
We can't look into the Linux which is running it. So maybe
your Linux is your own server. You can set up this on your own server.
The Docker image itself is based on mostly Linux.
Oh yeah, okay.
We can't,
the image,
we can't look into the VM itself if there is something done. So we must trust Google that they're doing nothing evil with the data which is provided to our hosted container.
Mostly yes.
Similar containers from other providers? So
I haven't found them yet, but they should be. So Google mentions that the server-side tagging is a concept, and they provide an image you can use, but you should be able to use other images. But the information of how to build such an image are very rare to not present, I think.
The tagging itself is still done by the browser.
The tagging is done by the browser.
And
you will see that.
to my own Docker. So it's some kind of semi-server-side tagging.
Correct.
Okay.
So it's called server-side tagging. I can give an explanation why I think they named it this way. But yes, I think it might be a little misleading in the first place. The expectation might be something else. I totally understand that, yeah. This is a demo site I set up. In this site, we have server-side tagging script implemented. Then we have two testing server containers, two tagging containers. Sorry, we have the mentioned server container and the web container, which is the default one you create when you do normal tagging. Let's say that. What happens now is, on the third thing, I will open analytics. So let's see. So I try to explain what we will see now and what is configured here. As you can see, there is a notice that the user data is not anonymized. The example will be able to anonymize some of the user data that Google uses to identify the user between inside a session and between sessions up to its IP address. We are able to anonymize this data completely before it's sent to Google. And as a little proof, I can show it in Google Analytics in the real-time analysis. For every request we do now, we get a new user. So every request is a new user for Google because these data will get anonymized. I can show. So I will reload 3 times. After this, I will show. I will give insight in the configuration. So now the real-time analysis will take a few seconds, up to a minute, I think, till we see it there. Hopefully, I see 3 requests, 3 users. Yeah, come on. 3 users. We have this because every user is every request is a new user for Google. So the configuration. Sorry, I will close this. This is the typical web container you might know from Google. We have tags configured. There are some tags paused. Please ignore these tags. These are experimental tags from myself. But we have a Google Analytics 4 configuration, which I think is nothing new. I will explain now. We have additional configuration parameters here, which tells Google Analytics that we use a server container so that the analytics scripts will get delivered by the subdomain and not by analytics. I think it's analytics.google.com, I think. So this is the only change we have here. And everything else is just default. We have a trigger for Google Analytics, and that's it in the web container. In the server container, so the server container introduces the concept of a client. So that's the part where I try to explain why it's called server-side tagging. The server container expects some sort of request you send to the container. So this container has its own URL, and you can send requests to this container. Every request you like. Then there can be clients which can capture this request. They can check, am I able to process this request? And these clients are need to convert this request into an event. And this event is then sent to the triggers, which might execute this event and fires the corresponding tag. So, in a short way, this is the concept. There are clients for server containers, but only for I think it's just for Google Analytics 4 and the GTM Web. There aren't much clients there. We can see Google Analytics 4. There's the old Universal Analytics, which is deprecated. The web container, and that's it. So in the web container, you configure your container ID from your web container so that when you load your container on your website, you will load it directly from your custom URL, and the request will be sent to the server container, and this client will capture this request and will send back to you the container's JavaScript. So it's the same JavaScript you will receive if you would call the web container directly, like in default configurations as that are done normally. Second client is the Google Analytics client. This client will capture every request that is sent as a collect request. So Google Analytics, when you want to track some data let's say in the default page view data, when a page gets loaded, a page view event is fired. And this event will not be sent directly to Google Analytics with server-side tagging. It will be sent to your tagging container. That's why we had this URL configuration in the web containers Google Analytics, so that the analytics script knows that it should use another URL to send the requests to. This client will capture these collect requests and will build an event from it, which is then sent to the Google Analytics platform. But between building the event and sending the data, you can change the data in any way you want. I will show that too. But first, we have even in the also in the server container we have event triggers, which are less than in the web container, because here we are listening to just for events the client will generate from the request. So the Google Analytics creates an event which is called page view, for example, page_viewed in lower cases, and then this trigger will listen to this event and then fires the Google Analytics 4 tag, which will then send the data to Google Analytics, to the platform. So I hope you can see that now. I will open the network tab so that we can have a look at the requests that are sent here. I hope it's, I think it's not that good, but let's see. So, correct. I will start here. This request above here, it's a little special Google Analytics. I can explain it later. But here in this request, the tag manager gets loaded. It says gtag./js and then some query params behind it. And the response of this is the default Google Tag Manager script with its data you can use. This request, I just want to say, as far as I can I examined, is not directly proxied to the web container. The request will end up in the server container. The server container will pull the script from the web container and then deliver it back, so that the IP address is not passed to Google Analytics. How I examined this is with the Google Analytics preview mode. I can show it to you. So hopefully this is all correct. So the Tag Manager script gets loaded with, together with the Tag Manager script. Wait. No, this one. Are delivered the Google Analytics tags from the web container you configured there, also with its triggers. So it's the same as I would call the, I would load the Tag Manager script directly from Google for this container. The next step is the Google Analytics script will get executed because of the page load. So Google Analytics by default has a page loaded event, which then sends the page view track event. This is this request. This is also sent to the tagging server. And the last request is just the scroll event. So when you load Google Analytics, it first sends a tracking page view event, and after 3, 4, 5 seconds, it will send a scroll event, even if you haven't scrolled. So it's just the behavior of the Google Analytics script. So we can see this request in the preview mode. The server container and the also have a preview mode like the web container. It's loading. We can have a look at the request. Yeah. Hello. That's a problem with live demos. No, it's not coming up. Oh, okay. Now we see something. So I will reload this page, and then we should get data in the Tag Manager debug. Should get. Now. So this is the request which loads the Google Tag Manager script. It's the gtm.js. And let's skip to here. So here we have the page view event, which is fired by the Google script in the first place. We see that this event, this page view event, fires the Google Analytics tag, which is configured in the server container. And this is all the data which is sent to the Google Analytics platform. So we have a client ID. This is the ID that Google uses and is stored in a cookie on your browser to identify the user between sessions. This cookie, I think, has a lifetime of 1 year. We have the session ID to identify a single user inside the session. We have a session number. This is just an increasing number by the events the user triggered for Google Analytics, so that the events of one session can be put in order. And last of all, I think we have the IP address from the user it is sent. I think these are the data that have the most privacy concerns. Every other data, we have the user agent, we have the page location. I think this is all more generic data, but this is the data that is that should be concerned in terms of privacy. So this is the original value, and we have a final value. As I was saying, we are overwriting these values with transformations. That's just generating, for every event, we are generating random numbers. We give Google some random numbers so that every user will be a new user to Google. And we also override the IP, in this case, just with some local default IP. Yeah?
Generating these values per request or per visit?
Per request.
Okay.
So when the user, let's see, we have this number is starting with 977 and 166 for the page view event. Then we have the scroll event. We can look into this too. And we have different numbers here. So every event the user triggers for Google Analytics will think this is a new user with, this is a new user with some data.
And the statistics are still valid?
No.
Okay.
That's a good question, of course. This should be an example what is possible with server-side tagging. You can think of, hey, I might be able now to track users without consent if I anonymize all the data. If this is legal or not, I don't know. But you could have this, you might have this thought. But as Ingo mentioned correctly, you might get problems with your Google Analytics data, because for Google Analytics, every event will be a new user, so you have a lot of new users for your site when you implement this. There might be solutions for this. One solution can be that you will track into different data streams in Google Analytics, so that you have a data stream for data given with consent, which is which has a high quality, and you might have a data stream for track data without consent, which should be handled carefully, but can be used to check how often has a user clicked on a special button. So, but might not be used in context. How many new users does my website have weekly?
But maybe page views or some events on the page, like click events or something.
Yeah.
Video
So,
content. And of course, you can talk with your privacy lawyer and discuss if it's also possible to give a random number to each user.
But of course, data quality is something you should keep in mind when implementing this. There might be customers where the customer says, okay, page views or don't know the English terms for everything aren't that important for me. I just want to know how often was this form submitted on my site, and if this is the only metric the customer wants, there should be no difference between tracking with and without consent in this case, or with an anonymized user, because the event is always triggered a single time. So I can I think I've switched the buttons. Sorry. I can unanonymize the user, and now it's the default tracking behavior for Google Analytics. When I reload, let's say, yeah, it looks fine. So when I reload 3 times, and we wait a few seconds, I should have only one new user here, because let's see, yeah. So we have one new user, and when we have a look into our page view, the data is not getting anonymized anymore. So I will give a quick look into the transformations, how we are doing this anonymization in this example, and then I will try to show you the setup in a really quick way. The transformations. There's the server containers has besides clients, they have a configuration called a module called transformations. And here we have a user anonymized transformation, which is quite simple. So in the event data, I will switch to tab back. You see that every data has its every data has its name. So, and we can use this name and override its value. We have a condition when this transformation should be executed. So in this case, I created a variable which I switched just with some JavaScript. And if this value is given, it anonymizes the data. For client ID and session ID, I created a custom variable to generate a random ID. You can do this quite simple with Google and with examples you find on the web. So you can use transformations with conditions to modify, add or delete data you don't want to send to Google Analytics. But I can tell you, if you delete the client ID, Google Analytics will not track this person. So it was not showing up in real-time tracking. That's why we modified it. We generated a random number instead of deleting it. But of course, you can use this to modify the user agent string if it leads to concerns for the privacy officers or everything you want. Some questions for this? If not, I will jump into a quick step. No? Okay. Yeah. Configuration. So, as I told, you need to create 2 containers. I think it's just here. No, I can't. What? Yeah. Create container. And when creating a new container, you can choose between web and server. So first of all, we create a server container. Venlo camp server. I will leave this open. And on the second, we create a web container. So now we have both containers. When creating the server container, Google Analytics provides you a wizard, as I said in the beginning, to provisionize a fully configured server-side container inside its own Google Cloud platform, so which is scalable with Kubernetes, I think so, and so on. Or you can tell Google, hey, I want to set up this manually. Then you get this configuration string. With this string, you can spin up your Docker images. This string has to be given as an environment variables into the Docker images. I will show. So I have a Docker compose file here, which is it's a really simple file. It's not long. Let's see. Does this work? Yeah. Cool. So there's only one image that is. Sorry. We have 2 services. We have a tagging container and we have a preview container. You need both services in order to run server-side tagging. The preview container is used for the preview I showed you, and the tagging container is the endpoint for tagging. This container can be configured multiple times if we want to scale it up. So you can have multiple of these containers for one server-side container. And you configure a privy URL you want your container to use, and the config string for this and for this. And for the preview container, you just say run as preview server true with the same image, and you're done. Now I have to shut down my default containers because of port conflicts. So five minutes left, I think. Yeah, I see. Why does it take so long? Okay. So now we have both containers running. And so this is the default script for Google Analytics, for the container. We don't need that. Now, ZDF SST, I have my index HTML, which is the page we just saw where I changed the tracking behavior with the nice banner. And yeah, this is the tag manager script we are using, which is the default tag manager script you get provided when you set up a new web container. Just the URL is pointed to your own server-side container with your server-side tag manager ID, container ID, sorry. So it should be this URL. Come on. Come on. So. Okay, so we should just replace that. Yeah. And now the basic setup for a tag manager is done. Now you can start configuring your tags in the web container and your client's tags and triggers in the server container to set it up the way you want. So to round it up, I want to go back to the content security policy. So as you saw, now every request is done by is using the subdomain of your configured server container. So scripts can be loaded without having additional content security policy, which is I think good and bad. So your content security policy can be way smaller for this because you just have this one subdomain where every tracking is done, and don't need to have these 6, 7, 8 Google domains which you need to have Google Analytics 4 together with the tag manager. But I think this cannot be set up without a developer, especially when you're going beyond Google Analytics tracking, because there are only clients for Google Analytics right now. So when you want to do a Facebook tracking pixel, you have to write your own JavaScript which captures the request. You can use the Google Analytics request for this, capture this, transform it into a Facebook compatible event, and then fire the Facebook tag for it. But this code you have to write on your own, but someone might have done it, so you might find some examples on GitHub or GitLab, but it is not provided as a default client configuration you can just add to your server container. Your server container just have a few configurations. So, in my opinion, this is more a concept right now with very few examples, but But I think it's an interesting concept which might help you with some privacy issues. You will get, especially in the next years, when you want to continue tracking your users with Google Analytics. or Google Ads for conversion tracking. So yeah, I think that's all of mine. So conclusion, yeah, better privacy, but as we saw, it requires a deeper investment of time and also expertise to set up all this, especially when you want to do more than Google Analytics.
It can also be used for first frames. It's harder to build.
Yeah, it can be used for better privacy, but it can be used for worse privacy. You can.
I can now just block all Google domains on my
of course,
firewall, and
of course.
I can't do that with this.
Yeah, of course you can't do it. You can block /collect request. So by default every request is done to the /collect endpoint. But for the server containers, there are paid services, third-party services on the web, which provide you with the server containers, not Google. There are other third-party services, and they provide you with features like, hey, you can randomize this endpoint. So yeah, then blocking this request on, let's say, with a PyO or something like this, it is way more difficult. Yes. Okay.